Okay, I'm going to go through the sit test on the computer, and this is sort of real, sort of fake, so hopefully this will be a good demo. This is something from some time ago, so I'm not even sure how accurate I'm doing, but at least you can see the process. So, first thing is you put the image from the camera into the computer somewhere. Then what I do is, it's a raw image when you take it with your camera. So you want to make sure you've done a raw image. So I'm going to go to where that image is. Oops, I'm sorry. I have to go to my Canon software, which lets me convert a raw image into a TIFF image. And so I'm going to pretend that I haven't already done this. So I take my raw image and I have my proprietary software that says convert and save into a TIFF, and then it creates this new format. So it goes from being about 18 megapixels to being about 103 megapixels when it's a TIFF. So it's quite large. Okay, so I've done that. Whatever you do with your camera, I don't know, but you have to take your RAW and convert it to TIFF. Once it's a TIFF, then ImageJ will now work. So I'm going to open up my ImageJ. So ImageJ has this little itty bitty screen. I'm going to check the camera and make sure it's all fitting in there, okay? Yeah, it looks like crap, doesn't it? Okay, so I'll say it as I do it. This is ImageJ, that's your whole window. You go File, Open, and then you go to that picture that you just saved as a TIFF. And so there it is. So I'm opening up my TIFF image. Now on my camera, I need to shoot it down low. I can't do it in the middle. I have to do it down low, because if I were to put it in the middle, then the razors on the sit test interfere with this and it messes it up. So I have to move mine to the lower part of the frame. You might not have to do that with yours. Okay, so here's the image. What we do is we go to Process, Noise, Despeckle. So that gets rid of whatever speckling noise might be in there. I've got some dead pixels in here, so they have nothing to do with nothing. Then I go to Analyze, Set Measurements. You want everything unchecked, except you want center of mass checked, and you want 3 on your decimal places. So they're taking care of that, and you OK. Then you go back to Analyze and go Set Scale. We are going to click to remove scale. That means we're going to measure in pixels rather than something else, and click OK. Okay, now we're going to take that image and we're going to change the type to RGB color. There's a new image. Then we go to Image and we're going to adjust it. Now Lonnie and Bill and I each have our way of doing it. I have found on mine that if I crank up the contrast and knock back the brightness, I get this guy that looks like that. Bill and Lonnie will probably argue with me about this. I would definitely talk to them. They're experts at this. I'm then going to enclose a box around each of these 15 slits. So right there, I got a box around it. I click M, as in Mike, on my computer. Boink. And it brings up this screen. It says 1, and then my X position in pixels and my Y position in pixels. I move the box over until that guy looks like it's centered. And M. Now each time it's doing this, it's finding the center of gravity of this slit image to 3 decimal places. So I'm just going to keep doing that over and over and over. I think when we were setting up that, I think I said that when we were set measurements, we were looking for center of gravity. In case I didn't say that, I'm saying it now. Okay, a few more here. So I should have 15 of these guys. I'm going to save, and I will save it as I will save the file as my image number. In this particular image, there's image 1058. So I'm going to go 1058, enter. So I just saved that as image 1058. I can get rid of all this junk now. I'm done with it. I have two screens, so I'm just going to slide this over from the other screen here. Now, this is the slit image test for this guy's mirror. And I haven't talked about setting up the mask and stuff. I'm just going to go ahead and put the data in. I'm going to go File, Open, Computer. I'm going to go to the place where I saved that 1058 that I just saved on my image J. I'm just going to open it up. So there it is. I'm going to highlight the 1 through 15 and the numbers just to its right, which are the centers of gravity in the X position. This gives you X, Y centers of gravity. We're just interested in the X's. We don't care about the Y's. I'm going to copy those two columns and then get rid of that. Then I'm going to go into my sit test, and under the word zone is a 1. I'm going to highlight it and click paste, which will plant those two columns right there. I'm going to change this box here, which is M2, to the image number 1058. That's just to keep track of what's going on here. Now that I've done that, I'm ready to run the test. So one of the things that we should have done beforehand would be Control M. That's your mask stuff. So I'm going to do that. Control M, enter, 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 enter. And now I'm going to, if you follow the instructions, it says enter the mirror data. We did that here. And then run Control M. We just did it. Now I'm going to, this pasting stuff is what we did here. Sorry. Now I'm going to run a Control F. F as in full count. So there we go. And here is the Excel spreadsheet display. So this is a Miller-LaCroix graph. Here's the tornado graph. Ideally, we would want all the numbers right down the middle. So as you can see, this mirror has a little hole in the middle, but otherwise it's not too shabby. But this isn't the, this is one display. This is the Miller-LaCroix display. If you want to see a profile of the mirror, then we're going to transfer some data over to the Figure XP. So here's the data that we're going to drag over to Figure XP. So bear with me while I just kind of get rid of this for just a shake. Open up Figure XP. And then I've already created a file for this. See, this is Lloyd's mirror. Okay, so that's what I've already entered. So, on Figure XP, if you've never used it, when you set it up, we have 15 holes, which is a center hole and 7 pairs of non-centered holes. So it's technically 7 zones. So that one's a 7. The next one says mark entry level or entry type. It's either effective or in or outer. We want effective. Units of measurement, I use inches. Light source, we're going to do moving. Radius of curvature, I measured it as 115 inches. Mirror diameter is 12.5. Desired deformation, its conic constant is -1. Okay, these next 7 entries here are the zone numbers that you did when you made your mask on whatever mill or router system you used. So you'd enter all those. I've already done it, so I'm not going to do it again. I go to the knife edge readings. So here we go. I'm going to come and take these batch of numbers and stick them in this column. Well, as you can see, I've already done that. And so they're already there. Now that I've done that, I can look at my service error. And there's the profile of my mirror. So like I mentioned from over here in the Miller-Croix, I'm going to slide these over so we can kind of split screen on one screen. On this Miller-Croix, you can see how it fell off the middle here. Well, here's where it fell off the middle. So I could move this guy over like that, and it tells me that I need to work as an anti-correction thing. Or you can slide it over like this and say, well, the whole mirror is actually not too bad except for the big darn hole in the middle. Well, I'm going to take care of that hole because I don't let stuff like that go by. So anyway, down here you can see how much glass you got left to polish out. Almost 5 cubic millimeters. Peak to valley wavefront error. As I move this razor setting, that changes. So we are roughly a third of a wave if I were to set that guy up right about there. Oopsie. Oopsie. I just can't seem to get that guy to cooperate. And here we go, right about boink. This scale changes as you move the positions here. So I'm about a third wave. I've got a Strill ratio of 76.5%, and it's got a surface RMS. So this tells me where I need to work the mirror. And if the mirror were done, I'd be able to tell the customer what his mirror quality is, his or her mirror quality is. So here's what we want. We want this peak to valley junk on this surface to be down like 11 nanometers or so. That'll move your Strill ratio up to about 995, and it'll give you a very tiny RMS. And that will make your peak to valley wavefront error somewhere around a 25th wave. So you're going to work until this is as small as you can. So my personal guarantee is I like this to be a 10th wave, and I like the Strill ratio to be at least 94%. And that gives an RMS on the wavefront, not the surface, but the wavefront of about a 33rd wave or so. A 26th wave would be sufficient. Alrighty. Bill and Lonnie will be able to add more to this. While we're here,